Good day, class. Now let us look at this tutorial question number 3 on the design of brake. The question says that the figure below shows a block shoe applied to a drum by a lever AB, which is pivoted at a fixed point A, this point A, and rigidly fixed to the shoe. The radius of the drum is 160 mm. The coefficient of friction of the brake lining is 0.3. If the drum rotates clockwise, that is, it rotates in this direction, we'll find the braking torque due to the horizontal force of 600 Newton applied at B. Now let us start our solution. Now let us take our given. Here we are given the radius of the drum R to be 160 mm, which is equal to 0.16 m. Then we are given the coefficient of friction, which is equal to 0.3. When you look at it, the contact angle here we have 20 degree, we have 20 degree. The contact angle 2 theta is 40 degree. Here we are going to assume that pressure is uniform over the surface. We are going to use the coefficient of friction. We are not going to calculate equivalent coefficient of friction in this case. Then we are given the operating force P, which is equal to 600 Newton. Now, from here, we are going to calculate, okay, from here, let R N be the normal force that is pressing the shoe on the drum, and Ft be the tangential force, We know that the tangential force is equal to mu Rn. Now let's take our Rn to be Ft over mu. Then the next thing we'll do is we are going to take moment about A. Take moment about A. So we are going to take moment about this point A. Now, we have three forces as usual. The normal reaction, which is acting upward, will generate anti-clockwise motion. It will generate the normal reaction, which is acting upward, will generate anti-clockwise movement. Then this tangential force, because it is below A, it will also generate anti-clockwise movement. While this force 600 will generate clockwise movement. For this reason, then we have Rn multiplied by its distance from this place, which is 350, plus Ft, its distance from here is going to be this one, which is going to be, which its distance from this place, which is going to be 200, this 200, then we'll subtract the radius of the drum from there. From here to here is the radius of the drum. So to get this place, it will be 200 minus the radius of the drum. So we have 200 minus 160, then equal to this force 600 multiplied by its distance, which is 350 plus 400. Then from here, we know that our Rn is equal to Ft over mu, and our mu is 0.3 multiplied by 350. then plus here 200 minus 160, this is 40 ft, then is equal to 600 multiplied by this is 750, then 350 divided by 0.3 plus 40 will give us 207 ft is equal to, when we multiply 600 by 750, it will give us 450,000. Then from here we divide both sides by 207. We have ft is equal to 450,000 divide by 207, and when we do that, it will give us 372.8 Newton. Then from here we can now calculate the braking torque. The braking torque TB we know is equal to tangential force multiplied by the radius of the drum. This will be 372.8 multiplied by 0.16, and this gives us 59.65 Newton meter. Thank you very much. Be expecting question number 4.